auger, these are two different types of McConkey auger. Two examples. What would they be? What did I say blood auger is?
I don't remember.
Selective or differential?
Selective.
Selective? What is it selecting for? Vampires? Is it selective or differential? Hmm? What is it looking? What is it showing you? Oh, let me ask that. What is it showing you?
It's like bacteria that grow on blood.
Okay. Is it just showing you to grow on blood?
Yeah.
Yeah, you did.
Go over all of that.
I'm a little lost right now.
We're here. We finished this.
Oh, yeah, I did. I don't know. You can wipe it.
Finish this so we're on the board of it.
Where am I? Oh, okay.
Hopefully they have them all mixed and stuff.
Oh, darn.
Right here.
Oh, yeah.
Selective and different, yeah. I was going the wrong way.
Yeah.
Let's just go home. I can't go laughing. All right, so selective and differential media, there are two different ones they use to ID different types of organisms.
Oh, yeah, we
You know
talked
what
about
they're gonna do. Selective means it's got something in it that is gonna inhibit the growth of some organisms but allow other ones to grow. Differential media means it's got something in it that's gonna differentiate different types. Can it use lactose? Can it ferment lactose and probably turn yellow, got a pH indicator in it? Can it grow in the presence of, what color do the colonies look if it uses a particular sugar? They differentiate, okay?
So the blood ones were selected.
I don't know which one. I want you guys to think about it. Look at these two. What you tell me, are they selective?
It's
or
got to be
differential?
selective because you want to know what's in your blood that is pathogenic.
Where the fuck
Blood
is
auger is
that?
differential media.
Differential.
You're gonna have three different types, and I know I mentioned them. You've got non-hemolytic, which means they grow on there, but they don't do anything to the red blood cells. You have beta alpha hemolytic, which turns them kind of a green color, and then you got beta hemolytic, which actually lyses the red blood cells. And this would be beta hemolytic because what's happened to the red blood cells where it's growing?
So beta, non, and what?
Alpha.
Alpha. Duh.
Gamma hemolytic or non-hemolytic. Alpha hemolytic, which means it just partially digests the iron inside of this. You get this kind of greenish color.
That's
Watch
right.
it. In beta hemolytic, they actually lyse the red blood cells completely. So if I have a tube of broth, not auger, that had blood in it, right? And I inoculated it with beta hemolytic organisms, what would happen to that blood eventually?
They would like.
It would do what? What would that media look like after a while?
Would it look?
Is it broth?
Go away.
Huh?
It's beta, alpha.
So it's gonna be liquid, okay, so guys, think of it this way. It's gonna be a
Mom
liquid
is
tube,
back.
right? And I've got that normal media, the nutrient media in it, but it's been spiked with sheep's blood, okay? So it's gonna be kind of red right now. I fill it full of beta hemolytic organisms. They're base strep. Yeast strep. What would happen as they grew?
What, did
What
they
are the
separate?
flavor?
Separated, what are they doing to the red blood cells here?
Making it less red.
Killing off the blood red cells.
They lyse the red blood cells, which means they
Yeah.
do what? They destroy them, right?
Mhm.
And they use up some of them iron and stuff in them. So this would eventually start turning what?
Clear?
Clear.
Clear. It could be cloudy because they're growing in there, but it would lose that red color because it's lysing the blood cells. Okay, so this is gonna be differential. Anything will grow in blood on there. They love it. It's got lots of goodies in it, so not gonna be selective, right? This is McConkey's auger. Now look at the two different ones on here.
Selective.
It's gonna be selective or differential.
Selective.
Selective, why? You get
Can you please
growth
just
here.
really quickly tell me what's the difference between selective and differential? I don't know why I don't
Selective
have that.
auger, selective auger has something in it that allows certain organisms to grow, but inhibits the growth of other ones. So you're selecting for something, high salt, bile salts, pH, something. Differential media, organisms will grow on it, but they're gonna look different somehow. They're either gonna look different, the colonies will be a different color.
Wouldn't that be differential up there at top?
These are the same auger, so what do you guys think?
Selective.
both.
Selective.
So, okay, so look here. got, like you said here, you got different color
Because
colonies.
you have
right?
colonies, yeah.
This one, do I have growth?
Yes, but it's also different color.
The colonies are a little bit weird, and this is normally gonna be what? It's kind of pinkish color and it's turning yellow. That means it's fermenting some sugar and producing an acid and the pH is dropping. Over here, it's still what color?
Pink.
Pink, right? So this is probably not fermenting the sugar that's in there, okay? 4, you've got growth, and it's turning it what?
Clear.
Clear. Over here, you don't have any growth, and this looks like this is probably bleeding over into this particular quadrant. So you have no growth. So which one is McConkey's based on this? Selective, differential, or both? Both. Good. Because it's selective because you're not getting growth here from something. And it has biosalts in it. It's designed to select for enterics, things that grow in intestine of animals. Biosalts are inherently toxic to most bacteria because they don't grow in it. So it's not growing there, right? Here, you've got 3 different growth patterns, but they all look what?
Different.
Different. So it's selective and differential. Virulence factor. I talked about virulence factors before. What does I say a virulence factor is? During your book.
How strong, like the viruses?
Not necessarily just viruses. It can be, a lot of these are gonna be more bacterial actually.
The prevalent, not
Okay.
prevalence,
Or the
but how
bacteria,
more
yeah, yeah.
Pathogenic?
Yeah, its ability to cause disease, how virulent, how sick can it make you, how easily can it make you sick? So we're gonna talk about toxins, adhesion factors, evasive factors, and invasive factors. Okay, we're gonna go through these in different. I think I have some. Well, here, let's go. I didn't find my slide. I'm gonna print up some examples of these later on and post them to you guys, because I had other stuff in here to do say. Because I want you, toxins, okay, toxins are what? What do toxins do? If something is toxic, what is it?
Like a
It's poisonous. What is it gonna do to the cells? Kill the cells. Toxins kill cells. They produce a toxin, it's gonna kill the cells. Adhesion factors are going to be things that allow the organisms to stick and stay put. Things called fimbriae, which are little hairs they can grab onto. Slime layers that are kind of sticky and stick together. So those are adhesion factors. If I'm, one classic example of adhesion factor is if you look at gonorrhea underneath a microscope, it's a diplococci, so it's got 2 cocci together, but it is just loaded with these fimbriae. So what does that do inside, let's say, the urethra or something like that?
it stays.
It allows them just to grab hold and stick and they don't get washed away. So if you don't have those, what's gonna happen? E. coli also has proteins that stick to receptors on the side of your cells. There are sugars that have evolved to interact with receptors on your intestinal lining. What's gonna happen if it's like a train? It's gonna attach, okay? So adhesion factors give the organisms the ability to, once they get in and colonize, they can form an attachment and stay there, okay? If you got rid of those adhesion factors in E. coli, what would happen?
You will get rid of it?
They would just get flushed out, right? Good. So stick. All right. Invasive factors are going to be things that allow it to evade the immune system. Things like capsules that both allow you to hide from the immune system and prevent phagocytosis. So it could be anti-phagocytosis. And hide. Not only hide, but evade phagocytosis. Does that make sense?
Yes.
These are things that allow you to evade the immune system.
So there's a surface protein also.
Those are going to be the more the adhesion factors, because those are interact with receptors on the cell surface. They're usually glycoproteins that interact with something that the cell receptor is going to be. It's got a normal. Your cells have receptors on the outside all the time, right? To interact with different ligands. Some bacteria have these ligands on their cell surface that mimic the normal ones, so it allows them to grab a hold of that.
I thought that helped in the weight, that where they would pass them because of
No, these are adhesion factors. They can still see a lot of them, they just can't. Now, remember, if you're very virulent, you're gonna have what? Just one of these?
Mm-mm.
You're gonna have all of these, right?
Yeah.
Okay. And invasive factors are going to be enzymes that break down things like collagen. They break down those tight junctions between cells, allow the cells to do what?
Penetrate.
Stick together, right?
Stick, yeah.
So that's what invasive, they don't kill anything, but they allow it to break apart these cell-cell connections, to eat through collagen. There's some of them that can actually eat through the skin. So
Wow.
those are allow it to invade
Yeah.
and get inside.
And those are usually enzymes.
Yes, they're gonna be enzymes.
Only, like exclusively or usually?
Usually, there could be some other things that are invasive factors.
Like-
Usually they're gonna be enzymes. They're gonna be
Okay.
catalytic enzymes that break down collagen. Well, there's one that actually, okay, there's one that strep uses to make clots for them. Called streptokinase. okay?
Yeah, the ACEs.
Why would that be an invasive factor? It would actually be an invasive factor.
An
and also-
evasive.
See, some of them do overlap. It'd be an invasive factor and an invasive factor. The clot, if you can get inside of there and you can make a clot form, you can hide inside of that clot, right? Will the immune system detect you?
No.
No, she's in a clot, it's going to get rid of this, then later on the bacteria can actually break out of that clot. So I will put a list of these up tonight.
Great.
So
Okay.
destroying the membrane, it doesn't kill it, it just kind of makes
Just
it
makes like a doorway.
vulnerable.
So this is your intestinal cell wall. It's usually one cell thick, right? These are all held together by different proteins. Tight junctions, gap junctions, desmosomes. Okay? And this is your villi. If the bacteria get in here, they can start secreting a toxin that breaks those apart. Now what can the bacteria do?
Enter the cell.
It can get inside of you, and it goes down here, and now you got a layer of collagen down here. So now it secretes collagenase, it breaks the collagen down, and now it gets into your bloodstream. And now it can eat it.
Get sick.
Replicate.
He can go for a little ride, wherever he wants to go. If it's bacteremia, he's just gonna go for a ride. If it's septicemia, what happens?
Destroy it.
What, huh?
Inflammation.
What's the difference between bacteremia and septicemia?
Fine.
Are they both bad?
Yeah.
Yes.
Both bad. Bacteria's got this idea.
Oh,
that-
it's
Sepsis is toxic
the other
blood,
one's
right?
circulatory, systematic.
Blood poisoning.
Bacteremia is the mere presence of bacteria in the blood.
And then septicemia is the growth of the.
Septicemia, they are growing and metabolizing and maybe even making toxins. Which one's worse?
Septicemia.
Septicemia, that's why you
So
saw blood for you,
toxins
when
is-
you got little red streaks, they used to say you get little red streaks coming out of your hand. Anybody ever talk about that anymore?
No.
I used to always have a friend there, you got red streaks, and I was a kid, I'm like, no, what's wrong with you?
What does that mean?
It means that's what they used to call blood poisoning, because it's actively metabolizing, it's eliciting an immune response, an inflammatory response, so you're getting that inflammation in those vessels. What is sepsis?
It's the systematic
Which one?
inflammation. Inflammatory response.
Out of control from,
Massive,
Inflammatory response.
yeah,
no, that didn't work either, never mind.
overly.
It's out of control, it's an overreactive response, right? Usually to something like septicemia.
Yeah.
So it's your immune system that's doing that. All right, so I will put up some examples from your book here to look over, all right?
Oh, fuck.
I had them on there, I guess I didn't say them. And if you take away a lot of these factors, pathogens become avirulent. So write that down too. Avirulent means it can no longer cause disease.
What?
Avirulent.
So they have to have
Some of them do. There's one of the pneumonia has a bunch of these fimbriae on it and a capsule. Capsule's gonna be here.
Evasive.
Come here.
What? No, evasive.
Sorry. Capsule's gonna be there. All you do is get rid of the capsule, nothing else. And it goes from being virulent to avirulent.
So like E. coli, that it has that new E. coli that's going around?
Which
that
one?
It just makes it more dangerous because it's more virulent?
It's 015787. It produces what's called a Shiga toxin. Shiga toxins actually, type 3 sugar, it's kind of weird. These type 3 secretion systems, don't write all this down, like why it's so bad. So here's one of your cells, right? Here's another E. coli. Little guys can cause a lot of problems. They actually have like a needle, and they inject the toxin inside of the cells. So that's why that one's so bad. Oh, it's 5-7. There's about 4 or 5 other ones too. I think they're called the big 8, the E. coli's. But that's the difference. It's actually got another what? Virulence factor in this case. It's going to be a toxin. All right. So we good on those?
Yes.
Don't post those up. Some of you all should already know these from micro. All right. Non-pharmacological intervention. Okay. Providing access to an infected site by antimicrobial agents. This is draining an abscess. If you have an abscess, what's an abscess?
It's a,
Bacteria what?
Yeah, build it with bacteria.
In where though?
Anywhere.
Anywhere in your tissue, right? It's an abscess. Okay. Technically, almost a pimple is almost an abscess a little bit, right?
It's known as gross.
So an abscess, if you get physical, if you drain an abscess, you're just doing what?
Taking out the pus.
And you're ideally getting rid of cleaning it out and cleaning out the pus. What is pus, by the way?
dead white blood cells, isn't it? Dead white blood cells and the thing it killed,
Bacteria.
like the bacteria.
Yeah, it's mainly the dead white blood cells. Usually the bacteria that phagocytosis and kills everything else. Usually macrophages, stuff like that die. All right. So you drain it out, you get rid of the pus, you get rid of the inflammation, you get rid of any leftover bacteria, you can clean it out, you can what else can you do to it? What else are you going to do in abscess? The part that hurts.
That hurts?
You ever had a really bad abscess drain?
No.
I haven't either.
I'm like, no.
They a lot of times they'll pack it full of what?
What?
Oh, that's right. So something like when they have it. What is the one by your coccyx? The tail where it's like
Tailbone?
hair and all kinds of stuff, and they have to put gauze inside of it.
Yeah. So if it's really bad, I mean, if it's a really big abscess inside of you,
What's that called?
this happens to animals a lot more than humans, but it does happen to humans. They'll actually do what?
Why?
Drain it, clean it out, and then pack it full of gauze.
So nothing else gets in there, I guess.
Yeah, you want to sort of keep everything apart.
It's gonna bother me. Do you know what that's called?
No, I don't know.
It's like right at the tailbone, and
You get an abscess there.
it's like a type of abscess, but it's from like
It's a specific.
like I guess kind of like ingrown hair. And they
Oh.
have to like it's really painful. They remove it. I need something. What is it called?
Watch Dr. Pimple Popper. Right? Give me an example of debridement. Classic example of this. Anybody?
What do you mean cleaning of the site? Isn't it just flushing it?
Debridement.
Just like what we were talking about, right? Like drainage of an abscess and cleaning it out
That's
and.
gonna be just drainage.
Cleaning the debris.
Debridement
Yeah.
is where you actually remove dead tissue.
Oh,
And this usually happens when? You know?
necrosis.
Scabs.
Good, no.
When
So
gangrene?
they usually don't do it for
Who
that.
removes it, like somebody?
Yeah.
Gangrene? No?
Gangrene's usually surgical. You could be.
Well, we're
could
talking about
include
surgical.
Debridement and cleaning the site. 3rd-degree burns.
Yeah.
This is
Oh.
debridement. All the tissue is what? Destroyed down to the dermal layer. To get healing going, you've got to do what first?
Take it out.
Got to get. Otherwise, you have. What are the 3 main concerns with 3rd-degree burns?
Dehydration.
Dehydration is the first one.
Infection.
Infection.
Infection is the second one. Whatever.
I always forget that one.
Like that pain.
Oh, temperature control. No.
What the third
Your credit. Go away.
Somebody hurry up.
Regulation.
Huh?
Body regulation.
Thermal
I said that. You told me. I said temperature control.
Oh,
You
okay.
didn't say it right.
Okay.
So
Extra credit then?
Debridement is classically done with 3rd-degree burns. They've got to get rid of that dead tissue because you've got to let what? New tissue either grow or you have to have a site for what? What's the other thing they have to do for 3rd-degree burn patients a lot?
What's the other what?
Other medical intervention, skin grafts.
Yeah.
You've got to get all that stuff done, skin graft, otherwise you're going to get infection. And this would be what? Removing infected organs or tissues. Appendectomy is where they move what?
They take out your appendix.
So this would also be, I would think, more gangrene stuff like this.
Oh, okay.
Debridement usually, don't get me wrong, and I will look it up and see, but to me, it's burn tissue. That's the only time I've ever heard of something being degraded, but I will double check.
So not even like when they get the flesh out of eating bacteria, the
That's
necrofasciitis?
usually gonna be what?
Still? It's not cleaning the site of debridement? You have to take off the dead tissue?
But your skin's an organ, no? So.
This
Yeah.
is where you're just actually scrubbing off the stuff. Here you're removing infected. You got infected stuff there, right?
Yeah.
This isn't infected. This is
Not
what we're talking
infected, okay.
about. Burn, right? It's damage or dead tissue.
Okay.
Now, maybe if you had a severe acid burn or something like that too, possibly electrical, any type of thing like that where the tissue's gone.
So it's physically damaged, that's the difference?
Right, because this is what, both of these are implying what?
Infection,
Right.
pathogens, yucky stuff.
All right, what's the function with true circular therapy is used in tandem with antibiotic treatment in some case of severe infection? True or false?
True. You just said that.
Something like gangrene, something like that would be something like that. Epidermal fasciitis, right?
Yeah.
Tetanus. Okay. Mechanisms that antimicrobials interfere, you need to know, I want you to know this, and we're going to get some examples of it. Interference with a specific step in bacterial cell wall. Beta-lactams, I want you to know that. No? Is that what you guys look up? Beta-lactam penicillin is in the beta-lactam group. Beta-lactams inhibit cell wall synthesis. Okay? Tetracycline is one of the ones that inhibits bacterial protein synthesis.
Inhibits what, sorry?
Protein synthesis.
Protein
Oh,
synthesis.
it's right there, sorry.
Interrupts bacterial nucleic acid synthesis. They don't use these as much because DNA is DNA is DNA, right?
Right.
So you have to be careful when you start monkeying around with DNA synthesis because it's very conserved. So some of these can be very what? Toxic, right? But I'll look up a couple, I think rifampin falls in that category. Interference with normal
So what is it for nucleic acid?
I'm gonna have to look up the drug. I want you to
Oh,
know,
I'm
'cause I
sorry.
usually go to the antivirals, but this one's specifically saying what?
Bacterial.
Bacterial. So let me find the new antibacterials that do it. An example of one. Interference with normal bacterial, these could be the sulfa drugs.
Yeah.
Sulfat.
Sulfa. Sulfonase, there's about 5 of them. They're generally the class is called sulfa drugs. They interfere with folic acid. DNA and RNA synthesis. They competitively inhibit one of the enzymes in this pathway. Did I go over that in here?
Yeah. Maybe
Okay,
in
so I'll stay right here.
micro.
So,
Wait. Rifampicin
rifampin, yeah, what is that, how does that work? Is it,
for the nucleic.
it is rifampin, right?
Yeah.
Put rifampin, but you don't, how do you spell R?
Rifampicin.
I just got to M.
Rifampin. Yeah, I thought rifampin did that. It's kind of a last choice antibiotic they use, they can also use it for some other stuff. All right, so this is gonna be like DNA, RNA, this is gonna be nucleic acids, right? The first step in this pathway is the enzyme that converts PABA to folic acid. Actually, to dihydrofolic acid. Then the next one's gonna convert it to folic acid. And the next is gonna convert it to the next one in the pathway. Then eventually you're gonna make what?
DNA, RNA.
DNA and RNA. The sulfa drugs inhibit this enzyme right here. So if you inhibit this enzyme right here, you stop making what?
RNA.
You've really kind of done this, haven't you? But you've done it through a metabolic pathway, not directly inhibiting it, right? Okay, so that's what we're talking about here. All right. Antimicrobial drugs can either be bactericidal or bacteriostatic. If you're bactericidal, they actually do what?
They kill?
They kill it. They're gonna got irreversible or lethal damage to the pathogen, they kill it. You give this antibiotic to it, you're going to kill that bacteria, right? Bacteriostatic If its inhibitory effects on the bacterial growth are reversed, then the agent is what?
Oh, it stops the growth, right? And then
This one slows or inhibits the growth,
Slows.
and then allows your immune system to take over and get rid of it, okay? Actually, a lot of antibiotics out there are bacteriostatic, people don't realize. Don't think about it. But I want you to go to the different thing. We'll worry about that later. There's no microclimate. All right.
Thanks.
There we go. This was in here somewhere. Penicillin and cephalosporins are both, monobactines are all gonna be what? Cell wall synthesis, right? The one I want you to know is the beta-lactams now. Aminoglycosides, tetracyclines, and macrolides are all gonna be protein inhibitors. So it says they bind to the ribosomes and inhibit protein synthesis. And once you know the tetracyclines. Sulfamides, I just told you about right now, folic acid synthesis. Quinones, don't worry about the glycopeptides, that's another one. Quinone.
That's like the last course of treatment though, right? They try not to use that because
Yeah, I'm trying to think if I'm trying to think if I'm about that. That's a levothyroxine, those are different. Yeah, let's look at the quinone, I think the rifampin may fall into this, but let me double check on that. Gotta get back, don't worry about the glycopeptides. I think micropharmacology. What are they teaching pharmacology?
lots of stuff.
What?
Well, drugs and how they affect.
You memorize them or what?
Yeah, pretty much. Pretty
They
much.
don't teach any pharmacology though?
well, I'm taking pharmacology at UTEP and we're actually going over those drugs right now.
Are you? Okay.
Yeah.
Then what do you do in there?
Well, we learn like what the drugs, like the contraindications, indications, the side effects. that
Side
kind of stuff.
effects?
Patient teaching.
Do you do any pharmacokinetics at all or anything?
What is that?
ADME,
Like what a pharmacist.
absorption,
Yes.
distribution, metabolism, excretion? Do you go there? It's like, okay. 'Cause that's what I thought they should be doing. I'm just telling you they don't do much of that.
Well, yeah, it just depends, because it shows the way that it's affected in different age groups.
Well, yeah, 'cause that all has to do with half-life, it all has to do with
Yeah.
counter-addiction. If you've got liver, kidney damage, how's the drug metabolized? If you have liver damage, it's metabolized the liver. What's gonna happen in drug half-life? That's part of the process.
It's gonna take a long time to make.
It's gonna take longer for it to metabolize the drug, so how does that affect you clinically, as a clinician?
You have to.
Oh, wait, can you have kidney or liver like damage?
Which one?
You can have kidney or liver damage if you don't like metabolize.
Right, so what if you have a patient comes in with severe cirrhosis of the liver? So they're gonna have decreased liver function, right? The drug you're giving is exclusively metabolized by the liver.
You can kill them.
How would you clinically, how would that affect what you would do?
How many times you give it to them, the
It would-
dosage?
It would affect the dosage regime, right? Because if it's gonna have longer half-life, you're gonna have to cut down the amount you give it to. Do they do stuff like that in there at all?
Yeah, well, we have to know why we have to do something. you
Okay.
know, so
Because somebody told me one time, that somebody, they said they just sort of make you memorize drugs.
No, you have to understand like why you're
Okay,
doing
good,
what you're
good,
doing.
good. I'll get a little word. All right, category 8, these are bioterrorism weapons. Plague, what is plague? What's the organism that causes plague? Anyone?
Bubo, like bubonic plague.
The
Oh,
organism
what's
that
it
causes
called?
the Black Death.
Oh, it's
plague.
the
Bubonic?
no,
Bubonic
it's called
plague.
something.
The Bobo?
Bubo, that's the massively inflamed lymph
I
node.
think it's not.
What is the organism?
It's the. Oh, I knew this one. It was our last test in micro. It's one that sounds weird. It didn't sound like anyone.
That's
Pestis, something
Yersinia
pestis.
pestis, yeah.
Ha, ha, ha. Sorry.
Tularemia, or rabbit fever. Tularensis.
Do we need to know what causes them? Like,
No, I just
okay.
want, I'm gonna ask you what there's a couple of them in each category. They're based on category, based on what, so let's go over these and then we'll go back and see why they're based on what category, right? Smallpox, hemorrhagic fever, Ebola, Lassa fever, Marburg virus, okay? Anthrax and botulism. Why would these all be considered category A bioagents?
Because
Toxins?
of how dangerous they are and how easily spread.
how infectious are they,
Is it because of their toxin?
how dangerous they are, and are there treatments for them and stuff like that, okay? Smallpox, is there a treatment for smallpox?
Yes.
There's a vaccine for it, so it's still a group A because it's not supposed to be around, but we know it is still around in a couple different labs. Ebola is why?
It's highly-
Hard to treat.
There were treatments for it. Really kind of hard to catch. Botulism, these are all group A. Group B, these are all gonna do what, or have the potential to do what to the person who catches it?
Kill.
Kill. Ages of foodborne and waterborne diseases, okay? E. coli, salmonella, shigella, listeria, cholera. Agents of zoonotic infections, these are gonna be passed on by something,
Animals?
from an animal to humans. They're not gonna be infectious. These are not gonna be passed on from person to person. These can also be passed on, most of them from person to person, not all of them. But are any of these gonna kill most patients?
No.
No. You just want to die.
It's gonna disable them, right? And again, viral encephalitis, again, it's gonna be West Nile, equine encephalitis. These can kill certain what? Immunocompromised elderly patients, you get bad encephalitis or, they can, but it's not like Ebola, right? And not like botulism. What are toxins from the castor bean? What is ricin?
Oh, it's that poison that they put to.
That's
Well,
like they
here
use
is-
that Breaking Bad.
Is it Breaking Bad?
Well, yeah, I think they used it, yeah. On Breaking Bad.
Yeah.
Isn't it what
The
they
Bulgarian Secret Service loved using ricin.
a biochemical, like a bioweapon?
Well, these are all bio-
Ricin? Oh,
It's a very potent protein, it's a protein synthesis inhibitor. So it completely shut down protein synthesis, all right? So if you were to swallow a bunch of ricin, what would happen?
You dead?
Yeah, you're dead. And it's very painful when you go.
Wait, what is it?
Shuts down
Shut
protein.
down?
Shut down
Protein synthesis.
Just shuts it down. All right, category CH, gonna be Mycobacterium tuberculosis, Nephovirus and hantavirus, tick-borne and yellow fever viruses, Cryptosporidium parvum. Any more down here? Okay. These are all gonna be what? Relatively hard to catch. Most of them have treatments, hantavirus is treatable now, yellow fever, there's actually a vaccine for. Clostridium parvum, Cryptosporidium parvum is more of one that's gonna do what? It's a parasite, it's a gastrointestinal parasite, right?
uh-huh.
But why are they considered weapons?
Because it's a weapon, for a bioweapon to work, is it need to kill people, especially civilians.
Well, that's what they want.
But do you want, is that necessarily what you want?
No.
Now, if I can take Cryptosporidium, which gives you really nasty gastrointestinal disease, incapacitates you, and infect the water supply, especially outside of a major city, what's gonna happen?
You're gonna infect a lot more people.
And what's gonna happen?
You're a terrorist.
Okay, what's gonna happen?
Well,
What's the, I'm not a terrorist weapon, I'm not trying to disinflict terror, I'm doing this as actually potential weapon.
Is it-
How that affects my ability to move into place?
Isn't it like incapacitating people so
Oh,
that you
well,
could
yeah.
take over and then kind of make them your slaves?
If you, not your split, but if you've
Once they get
got-
better?
If you've got half the population still in the military, first responders, medical people, all sick as a dog and incapacitated, what happens to the infrastructure of that whole place?
Falls apart.
It just falls apart. So you can do something like that. Some of these weapons are designed, you don't need to kill, you just need to incapacitate people.
Or incapacitate people so that you can sell,
Sell them?
no, sell like to heal them, fix them.
the medicine.
Oh, like big
pharmaceutical
pharma.
Oh, well, yeah,
Yeah.
well,
Like big
that's a whole
pharma.
conspiracy. But you could, I mean, any of these, like, something like crypto would do it, TB not so much. That's why none of these are really that bad, they have, hantavirus looked really bad a while back, but they figured out how to treat it. But the influenza, what would happen if you had that massive influenza outbreak of one that the vaccine didn't work?
Ooh.
Who's gonna get sick first?
The kids and elders.
The kids in the school and the elderly, then they're gonna come home and spread it to who?
Families.
Mom and dad. And this is one of the ones that kills a lot of people, like the bird flu they're worried about. Now, these people are going where now?
To the hospitals.
To the hospital. Now who's getting sick or not going to work?
Doctors.
Responders.
Those first responders and the doctors and the nurses. So now you have no medical treatment for these people because they're either dead, sick, or they're not going to work. Okay, now what about people running the sewage treatment plants? What about people running the power plants? How
Yeah.
about the truck drivers? Now what happens to the entire society?
Falls apart.
Collapses. So some of these things you don't have to kill, you can just accept passive.
Okay.
Has that ever been done?
They're dictators have used bioweapons in the past and stuff, hey, somebody else has approved it yet. What's the scary thing about biological weapons?
You can't see them?
You keep me off talking and we put the whole class on you know what happened. What's so scary about biological weapons?
You can't stop them. You can't
The
see
sequence
them.
might take a while to show.
Some could, but you may want to factor that in there. I always tell my micro about how I'm making a new bioweapon. I'm afraid Homeland Security is going to come and help on me. But what's the other thing about them?
The way they work, I guess.
How much infrastructure do you really have to make bioweapons?
Oh, they're cheap
How
and
much
easy
money?
to
You have
make,
to a bunch
yeah.
of nuclear material.
No, you can get it from the ground when you were
You
telling
can
us.
just go to biological supply companies and order everything you need. I could grow anthrax from the field down there if I really want. So they're cheap. What's the only hazard with bioweapons though?
That you could get sick yourself.
Can backfire on you sometimes. All right. These are just global issues. SARS, severe acute respiratory syndrome, that was, they thought was a big deal.
Did you add that?
Zika,
No,
they're about ready to come out with the vaccine
Yeah,
for
okay.
anyway, it's kind of much about nothing. West Nile virus, again, it's just sort of a what? I don't know.
SARS, Zika, and what else?
No, West Nile, just,
Oh.
these are just global issues, they're global, things are gonna have pandemic effects, right? Possibly. All right, okay. So we gotta hear, sign the sign-in sheet. If y'all haven't signed one of these things yet, maybe I'll wait until Wednesday when more people, it seems like there's a lot. So.
Are you gonna review the test, or are you gonna put something online like the?
We'll do something Wednesday, we'll figure out something. I'll either put it online, the answers, or we'll review or something.
Okay.